Let's go through the first question here. Find angle DBA, it says over there. All right, so geometry practice questions. So we want to find DBA. We go to D, then we go to B, then we go to A. So D starts here, right? Then we go to B, then we go to A, and you can see that angle over there is theta. And that's the angle we want to find.
Yeah.
Now, we also know, we can see that this is a triangle where we have a diameter. Can you see the diameter?
Yes.
All right, so if you can see the diameter, then automatically you have angles in a semicircle, and angle D is equal to 90 degrees. So the first thing we write is angle D is equal to 90 degrees, and the reason is because of angles in a semicircle. All right, so angles in a semicircle gets me that to be 90 degrees. So therefore, angles in a triangle now will add up to 180. Angles in a triangle add up to 180. So angle C will equal 180 minus 90 minus 48. And that'll come to 48 plus 42 gets you 90. So this must be 42 degrees. And the reason is angles in a triangle equals 180 degrees. The three angles. And we're only looking at this triangle now, nothing else, right? Okay, now that we have that, we can then go to the next part and see, okay, well, that is also going to equal 42 degrees. And this is part of your cyclic quads theorems. And in this case here, we're going to say theta is equal to 42 degrees because of angles in the same segment. Now we have to memorize these reasons, right? Remember,
Yeah.
semicircle is to do with 90 degrees. Same segment, it looks like a butterfly. The moment you see a butterfly, then you know that those two angles are the same, and those two angles are the same at the top. So angles in the same segment mean that if you have a circle and you have 4 points touching the circle where we are crossing them across from D to B in the form of what looks like a diagonal, and AC on this side, forming a butterfly, you can see that's going to be angles in a segment. This angle will be theta as well. And then if this angle was, let's say, alpha, then this angle will also be alpha. And you can also extend this. You can extend this from this side. You can extend it all the way this way, let's say, hypothetically speaking, some angle on this side. This will also be theta. And you can go all the way down till the bottom, right till the bottom there. That will also be theta. No matter where, you can bring it right till that end there. That will be theta as well. So the angles are sort of always equal no matter what. It's basically a chord that's subtending. We use the word subtending. In other words, that angle is opposite this chord. Okay. And angles in the same segment from there is a short way of writing it. Okay. So 1, 2, 3 marks there, 4, 5, 6 marks for all of the reasons. Okay, let's go to the next one. Find angle OZY. Find angle OZY for this next one. Okay. So if I want to find angle OZY, the first thing I can see is I first have to locate the angle. Let's locate the angle. So we start at O, then we go to Z, then we go to Y. It lies at Z. There's O, there's Z, and there's Y, and there's theta. So sometimes they don't give it theta, they've marked it off here. I want to find this angle. The best way to start these questions is to look at what you have and what angles can you find, right? So look at all the angles that you know that you can find. So this angle here is going to be, this angle 58 is going to be angles in a triangle. And you can see that this is an isosceles triangle. Can you see that? Because this is a
Yes.
radius and this is also a radius. So these two angles can be found by finding angles in a triangle, minusing it from 180 and dividing it by 2. So let's do that. Let's find these angles, all right? I'm going to also call this x1 and x2. I'm going to call this z1. and Z2, and this is Y and that's W because we have two options. I'm going to call this O2 on the other side and O1 on that side. Okay, so O2 is this big, massive reflex angle. All right, I'm just going to use that terminology for now. If I take X1, all right, if I take X1 plus Z1 plus 58, it'll come to 180 angles in a triangle. But I also know that angle X1 is equal to angle Z1. And the reason is because of radii. All right, because these two radii are equal, we say radii, you can write radii equal. And also, it's an isosceles triangle. Just check with your teacher to make sure that you got the reason that they want as well. And sometimes also known as angles opposite equal sides. All right, angles opposite equal sides. Angles opposite equal sides as well. So x1 is going to be equal to z1. Therefore, I take 180 degrees minus 58 degrees and I divide it by 2, I will get x1 or z1. And that's angles in a triangle equals to 180. Put it on a calculator. Let's grab a calculator. 180 minus 58. 122 divided by 2 comes to 61. So angle x1 or z1 is equal to 61 degrees. Write it in your diagram because then you can actually have more visual understanding of where you need to go next and what you need to do. Now you want to try and find as many missing angles as possible. You can try and find this one. You can try and find that one. The one thing you can see also is that this whole shape over here is a cyclic quad. It's a quadrilateral where all the corners touch the circle. Okay, so you got the cyclic quad. So let's look at some properties of cyclic quads. Did you know that the opposite angles of a cyclic quad add up to? The opposite angles of a cyclic quad add up to 180. 180.
The whole thing is 360.
Yeah, because it's supplementary, right? So we would say angle Z plus angle W is equal to 180 degrees. All right, and the reason is because of opposite angles in a cyclic quad. Now we know what Z is. Z is made up of 61 plus theta, and W is 69. So now we have enough information and we can solve it. 61 plus 69 equals 130. Theta plus 130 equals 180. So theta is equal to 50. So the answer for theta is 50 degrees. Opposite angles in a cyclic quad gets you that over there. All right, with reasons, I mean, give yourself, you can, with reasons, give yourself up to 6, maybe more marks for that. All right. Okay. All right. Let's have a look at the next one. Show ST is parallel to QR. So we want to show that these two are parallel. When it comes to parallel lines, you can prove corresponding angles, you can prove alternate angles, you can also prove co-interior angles. Any one of those three. In this one here, I don't see any F shape. If I draw a line across there, yes, maybe I've got corresponding angles. If I draw a line across there, I can also see that that's going to be co-interior angles. But there is no line that's cutting across where if I had to continue the side, maybe those two would have been co-interior, right? So I can't see corresponding or co-interior, so I must most probably be dealing with some alternate angles. So if I look at this here, I can see S and Q will be equal. So I need to show it's parallel. I don't know it's parallel yet. So to show ST is parallel, I need to show angle S is equal to angle Q by and proving alternate angles, right? Or angle T is equal to angle R. So I've got to prove that that's equal to that. And if I can do that, either one of those, then I'm done. Then I've solved the problem. So let's have a look at how we would do that, right? Okay, so I'm going to erase this. We don't know this. We're assuming that's what we need to get to, but we haven't got there yet. I'm looking at the center, and I can see the butterfly. I can see angles in the same segment. So I can see already that angle T is equal to angle Q. Let's just write that down. Angle T equals angle Q, and I can see the reason is angles in the same segment. And then angle S is equal to angle R, also angles in the same segment. Angle S is equal to angle R, angles in the same segment. But we need those two to be equal, and we need those two to be equal as well. So what I'm going to look at now, I say, okay, well, this is the center, right? And this is now, therefore, a diameter. And because this is a diameter and that is the center, I can maybe use that to my advantage. I can divide it by 2, right? So this must be my radii. So all four of those lengths, this length, that length, that length, and that length, they all equal. All equal, right? So if that's the case, then what kind of triangle is this? An isosceles, and this one, an isosceles. So what does that mean? It means that those two angles are equal, and those two angles are also equal. So that means all of these angles are equal. But now we're going to write it down. We're going to write it down. So we're going to state TO is equal to SO because of radii. Therefore, angle T equals angle S. And the reason is angles opposite equal sides, isosceles triangle, I'll just write both. Okay, isosceles triangle, angles opposite equal sides, base angles of a triangle, of an isosceles triangle, are equal as well. Similarly, then you can write down the word similarly so you can save time. Similarly, like T is equal to S, Q is also equal to R. So if Q is equal to R and T is equal to S, then therefore angle S is alternate to angle Q, and angle T is alternate to angle R. And so therefore TS is parallel to QR, and then we stop there because of alternate angles here. All right, I'll send a video with the assignment after this, right?
Yeah.
All right. Let's look at the next one. The next one you got is, so it says here, question 4, JK is a tangent. All right, you can see that tangent there, touching the line, touching the circle on the line at one point, at a single point. Okay, so JK is a tangent intersecting at L. There's L over there, all good. If angle LPN, all right, angle LPN, let's go to LPN, that's this angle here, is equal to 2 times angle MLK, is equal to 2 times this angle. So if this angle is X, this angle is 2X. All right, if this angle is X, this angle is 2X. Let's make a note of that. Let's just get it more neater there. So this angle over here is X. So this angle over here is 2X. JK is a tangent intersecting at L. if LPN is equal to 2 times MLK, show that LM, let's go to LM, all right, you can see LM is this one over here. Show that LM is the same length as MN. All right, so we're going to prove that those two are equal, LM and MN. So how do we prove that those two are equal? That's the question now. Normally, let's suppose I draw a line straight across here. And I prove that this angle is equal to this angle. If I prove this angle is equal to this angle, then it's an isosceles triangle and we're done. If I draw a line LN. So I can do that. I can construct a line LN and I can prove that as well. All right. Okay, so let's see. Do we need to do that? We got x over there and we got 2x over there. I can see angle at the center here is equal to 2 times the angle at the circumference. And that's one of the reasons there. Angle at the center is equal to 2 times angle at the circumference. Another thing I can also see is that there's a cyclic chord here. The cyclic chord, and therefore if this is 2x and this is m, those two angles must add up to 180. So angle m is 180 degrees minus 2x. So let's start from that. We're going to start from just getting as many angles as we can see. So let's start. Angle m is equal to 180 degrees minus 2x. And it'll be opposite angles of a cyclic chord. Are supplementary. Let's just put the word supplementary as well. So that means this angle is double of that, right? It's double that one there. So angle O is equal to 2 angle M's. And that's because the angle at the center is equal to 2 times the angle at the circumference. So let's multiply 180 and 2x by 2. We'll get 360 minus 4x. All right, so that's 360 minus 4x. Let's write it in there. 360 minus 4x. Now, angles around a point add up to 360. And if this is 360 minus 4x, and surely this angle on the other side, this reflex angle must be 4x because it adds up to 360. And that's how the angle at the center on this side is equal to 2x, because this is the angle at the center is equal to 2 times the angle at the circumference. And 2x times 2 is 4x. All right. We've got all of that. We're getting as much information as we can. So far, so good. I can see this is x. All right. And we will still want to prove. We want to prove that this is equal to that somehow. All right, let's do that construction. Let's put that construction in. I'm going to construct L in. All right, let me write it down. So construct L in. I'm going to call this 1, 2, 3, and 4, and maybe even that one there, 5. I'm going to call this 1, 2, 3, so we know which angle is which. I need to prove that L2 plus 3 plus L3 is equal to N2 plus N3 is equal to N2 plus N3. All right. L2 plus L3 must equal N2 plus N3. And if I do that, then I'm good. Now, from this, I can see that this is radius equal, 2 radii which are equal. So already I can see L2 is equal to N2. Okay, so let me write that one down. L2 is equal to N2 because of radii, and angles opposite equal sides or base angles of an isosceles triangle. Those two angles over there are done equal. So I got to prove now that L3 is equal to N3 somehow.
Yeah.
Now, how do I do that? How would I find that? So in order to prove that, there's another theorem that I'm going to bring up now, which is called Chord Theorem. All right. And Chord Theorem says that if you have a triangle and this angle is equal to x, and this is the triangle, right? And that's the angle that's equal to x. I'm saying that, let me use a bit of a highlighter. So this angle over here is equal to these two angles combined. And that is called, you can see there's a triangle here that we're working around. So it's in this triangle. And this is called Chord Theorem. All right. So when you have a tangent and a chord, that's what happens. Okay. Another way we could also prove this is we could have done this. We know that this is a tangent, and we also know that tangents and radii meet at 90 degrees, right? So this angle L3 is equal to 90 minus x. All I need to prove is that N3 is equal to 90 minus x, and then I'm done. Now, if I look at this shape over here, I've got 1, 2, 3, 4 sides, right? Angles in a quadrilateral add to 360 degrees. So N3 is going to be equal to 360 minus the sum of the others, which is 4x. So that plus that plus that plus that. This here plus this here plus that there plus that there will equal 360 degrees because it's a quadrilateral, but in the shape of an arrow. So 4x plus 90 minus x plus 180 minus 2x. And I can get angle N3. 360 minus, now 4x minus x gets you 3x. 3x minus 2x is x. 90 plus 180 is 270. And then 360 minus 270, 360 minus 270 will give you 90. So therefore, you get 90 minus x, and that's equal to N3. So therefore, L2 plus L3 is equal to N2 plus N3. All right, L2 plus N3 is equal to N2 plus N3. And they are bases of a triangle LMN. So therefore, LM is equal to MN because it's isosceles. You can state on those lines, therefore it's an isosceles triangle, and that's how you would end up finding that one there. Okay, now let's give you a second to think about maybe the next question I'm going to put up. All right. Next question is going to be this one here coming through. All right. Try the first one and see if you can work from the first one here. Question 1. Yeah. Try and find ACB. All right, so let's have a look. So the first thing we're going to do for this one here is we can see that the angle at the center is equal 2 times the angle at the circumference. So if I call this O1 and 2, then angle O1 is equal to 2 theta. And then I can also see that That's 2 radii. So OB is equal to BA because they radii. This was angle at the center equal 2 times the angle at the circumference. And because this is radii, this is also going to be 53 degrees. So therefore, angle A is equal to 53 degrees. Angles, base angles, I'm just going to write base angles of an isosceles triangle are equal. So that means we can add these 3 angles up, and it'll add up to 180, and that should be enough information to solve it, right? So you could take, this is one way of doing it. I can't see another way of doing it. So if I go 53 plus 53 plus 2 theta, it's equal to 180 degrees. That's 106. 180 minus 106 would give you 74. So theta is equal to 37. So 37 degrees. Theta is equal to 37 degrees. Okay.
So you know how you got 2 theta equal to 74? Did you just half that?
So I took 180 minus 106. Yeah.
Okay, yeah.
Yeah, so I just minus it on the side and then divided by 2. Yeah. Okay. All right, now there's another way to do this. If you started off this whole question, you realize that this is a diameter, then you'd realize that this is 90. Okay, and if this is 90, then 90 minus 53 will be this angle over here. So you could have written angle B is equal to 90 degrees, angles in a semicircle. And then therefore 90 minus 53 gets you 37, right? So this angle B, let's call it B1 and B2. Angle B2 is equal to 37 degrees. And then again, we have radii, which are equal. OB, this is O, OB and OC are equal because of radii. So therefore, angle B2 is equal to angle C. And therefore, theta is equal to 37 degrees because of base angles in an isosceles triangle. All right, let's try the next one after this one. All right. Try this one over here.
Yeah.
So I can see the angle at the center, which is over here, right? This angle here. That's the angle at the center. Now, if I take those same 2 lines and I go to the end, that's the angle at the circumference. So in other words, these 2 are let's say that's the angle at the center. I can see that angle is at the circumference. Now the angle at the center is equal 2 times the angles at the circumferences. So with that said, I can already see that this angle is equal to theta. Angles in the same segment. And because this angle is double any one of those, this one here will be 2 theta. All right. And then I can also see that these 2 are radii. So what will this be?
That one would be the same as that one.
Yeah. 42, right? Angle at and this one's angle at center equals 2 times angle at the circumference. And then this is 42 over here. All right, try that. And let's see if we can finish it off. Try and write it in one step by step. All right, let's put it together. So now what we have here is this is our last question, right? And this is going to be W. We started from W, so we'll say W equals theta because of angles in the same segment. And then angle XOY, angle XOY is also equal to 2 theta. angle at the center equals 2 times the angle at the circumference. And then from there, we've got radii which are equal. So OY equals OX. And therefore, angle OXY will be equal to 42 degrees. And it will be base angles of a triangle, of an isosceles triangle. So therefore, if we add all these three up, we got 42 plus 42 plus 2 theta will equal 180. That's angles in a triangle equal to 180 degrees. That becomes 84 plus 2 theta equals 180. 2 theta is equal to 96, and then therefore theta is equal to 48 degrees. And that's done.
Alright, good.